So firmware is the operating system of the microprocessor, as we just discussed. It is something that will translate your Python commands and programs into the binary instructions that ESP will understand. We will first download the Python-based firmware on the laptop and use the ESP tool to load the firmware into the ESP. Our firmware that we are going to use in this video today is called MicroPython. This is not the only firmware for ESP. There are other choices. For example, if you are working with Arduino, you will load the firmware that can understand compile C code instead of Python code. For our purposes though, today we are going to use Python. So we can head over to the MicroPython website like shown here. You can certainly search it through Google. That's usually the easier way. And for those of you, who want to go directly through this site, I'm also providing the download location in the description. So we search on Google for ESP8266 MicroPython, and that brings us to this page. Then we select ESP8266 chip. It brings up three choices right here. Most likely you are working with a NodeMCU board that has a flash memory of 2 megabits or more, and the middle choice or the middle option is the binary file you want to download. If you are not sure what flash memory you have, you can look at the specifications of your purchase, and that will usually tell you what is the size of the flash memory. Like I said before, the most common size is about 2 megabytes, and so the middle option is the right option for you. We go ahead and download that. Download the latest version. Now notice that this is not a file that you can download by double clicking. We have to use the ESP tool in order to load that into the firmware. To do that, I'm just going to do a little bit of house cleaning. I'm going to create a NodeMCU folder for my work here, and I'm going to copy over that binary file into my NodeMCU folder. You could directly work from your downloads folder also, but I just prefer to keep a separate directory for all my work, and this just makes it easier to make sure that I have all the things that I needed in one place. Okay, so at this point I have copied over the ESP8266 binary file into my folder, and I'm ready to load it to the ESP8266 chip. As a first step, we are going to use ESP tool. Before loading the firmware, we need to make sure that the flash memory is clean. So what I'm going to do is erase everything in the flash memory using the ESP tool, using the command shown here. Notice the command is pretty simple. We start with esptool.py, provide the port number that we copied from the /dev in the previous step, and we just use the subcommand erase flash of the esptool.py. That's all you need to do. You will observe that when the command is running, the LED on NodeMCU is blinking. Usually this process takes about 10 seconds. Sometimes it can be faster or slower depending on your connection. Okay, so for me, in this case, it finished in about 7 seconds. The next step is to upload the firmware, which is the binary file we just downloaded, and that is also done using the ESP tool, and the command for that is slightly longer and looks something like this. So once again, we start from esptool.py, provide the port number, then we provide something called the baud rate, which determines how fast the load will happen. For the Silicon Labs USB to UART converter, the default baud rate is 115200 bits per second. So I recommend that you use that just to make sure that everything goes smoothly. Later on, if you are so inclined, you can experiment with faster baud rates that could make this loading go faster. And now note that you only have to upload the firmware just once. So it is okay to do it a little bit slowly using the default baud rate. We are going to use the command write flash, and then the rest of the options such as verify and flash size detect -fmdio0 and the ESP, the name of the binary file that we need to load. These are all standard. If you want to know the explanations for these different options, please head over to the ESP tool documentation, and there it is explained in greater detail. So now we run this command, and at this point it should begin uploading the binary file, and it will take maybe 30 seconds for the upload to complete. Okay, so if your output looks something like this, the upload has completed successfully, and at this point we are almost ready to begin programming our ESP chip.